Gravity and space. Gravity is one of the four fundamental forces of nature and acts on anything with mass. We are standing on planet Earth, and so gravity is acting on us. Because the Earth is so heavy, gravity pulls us down towards the centre of the Earth. Regardless of where you are on the Earth's surface, you're always being pulled towards the core of the Earth. In order to work out the size of the force of gravity acting on an object, we need to know the mass of the object in kilograms and the strength of gravity on the object. For example, if you're on the Earth, you need to know the strength of gravity of the Earth. This would be a different value if you were on Mars or the Moon or somewhere else in our universe. Luckily for us, on Earth, the strength of gravity is just below 10, so we can round this up to 10 newtons per kilogram. Therefore, to work out the weight of an object, you simply times its mass in kilograms by 10. So in this example, if an object had a mass of 5 kilograms, times it by 10, it means that the force of gravity acting on that object due to Earth's gravity is 50 newtons. We call this an object's weight. Here we have a picture showing the Sun, Venus, and Earth. The mass of Venus and Earth are similar. The force of gravity between Venus and the Sun, though, is about 1.6 times stronger than between the Earth and the Sun. This is because Venus is closer to the Sun. So the strength of gravity not only depends on the mass of the object, it also depends on how close you are to the object. Therefore, if you were to go on a spaceship away from Earth, the strength of gravity acting on you would decrease. However, always remember that there is gravity in space. It is a common misconception for students to think that there is no gravity in space. This is incorrect. Here is a table of data showing how the diameter of a planet in kilometers is related to the planet's gravitational field strength. You will see that the Earth there is stated as 9.8. In general, the larger the planet, i.e. the bigger the diameter, the greater its gravitational field strength. This is simply because bigger planets have more mass. However, this is slightly complicated by the gas giants, which you can see are much greater than the Earth in diameter, and yet their strength of gravity is similar, if not slightly less, in the case of Uranus. Now, you might be asked to use that data to work out fractions and percentages. Here we're trying to work out the fraction, or as a decimal, between the diameter of Mars and the diameter of Earth. If you divide the two numbers, you can see that the answer is 0.532. This tells us that the diameter of the Earth is nearly twice the diameter of Mars. In another example, you might need to convert from a percentage to a decimal. So here we have the gravity at the surface of the Moon is only 16% of the gravity at the surface of the Earth. Write this as a decimal. To convert from a percentage to a decimal, you simply divide by 100. Although the numbers might be different, slightly larger or slightly smaller, all of the things you'll be asked to do in a science assessment are the same skills in maths that you've been taught in your maths lessons. Thank you.